What do you do if your goggles start to fog? Because mine are like...
Just air it out. Sweating, same.
Hi guys, and welcome back. Today we're going to be doing something a little bit different on my channel. We are going to be doing a science experiment. And to guide us through this experiment, which of course I would have no idea how to do since I scored a really low grade on my test in science. I think the lowest you can actually get before remedial courses in college, but I got a perfect score in the English, so we're just not going to talk about that. What is your name? What do you do? What are we going to do today?
Alright, well, I'm Brianna, and so I went to school to be a chemical engineer. So I got my bachelor's in chemical engineering. I'm actually in a master's program right now. It's in engineering technology, but it has a concentration in occupational health and safety. So what I do is I work at a manufacturing company as an environmental health and safety specialist. So I protect people and protect the environment using science, basically.
Wow. So is this a predominantly male-dominated field, or?
You do see a lot of men in this field. You see more women now, I think, than you used to. You know, anytime you have engineering, a lot of times you'll have male classmates, male colleagues.
So today it's going to be hopefully a really cool experiment. I have no idea what we're about to do, and like I said, I'm not very good at science, so I hope to learn from our lovely chemical engineer here. So
Great.
let's get started.
Well, first and foremost, anytime you're working in a science lab, safety is priority. It's the first thing. That's what my career is. I keep people safe, and that includes myself and you now, since we're doing science together.
I'm
so
the chosen one.
You are the chosen one. So we have some goggles for
Ooh.
eye protection that we'll wear anytime that we handle chemicals or anything that might potentially be flammable.
Did I put these on too soon?
No,
Or
you can
shall
model
I
it for us.
just-
It looks
shall I
good.
just
How's
roll
it
with
supposed
it?
to look? Also, another thing that's really important is making sure that when you have long hair,
Wait, I have to take this up?
yeah, just
This
pull,
is my crowning glory.
Pull back a little bit.
Great. Should I have done this before the goggles?
No, it doesn't
Okay.
matter.
I
You
just
do
want to
it
make sure
now.
that I
whatever
look
makes you
amazing.
feel safe. So you'll pull your hair back. Again, depending on chemicals you're working with or anything that might catch fire, you don't want your hair to catch fire, so you're gonna pull that back.
I 100% know how dumb I look right now.
You look great. All right. It's important to have something to protect your clothing or anything that might spill on you or your skin. So lab coat is also important to wear as well.
Awesome. We have covered these lovely names with duct tape because we don't want any of you to stalk Bree. Because I know you will. YouTube, you are insane. Watching you.
All right, so you ready for our first experiment?
Yes. Oh, by the way, you didn't explain what your shirt meant. So for us lay people, what is your shirt mean?
So this was a gift. So it is themed for different bands. And so you can see the atomic symbol here for Iron Maiden.
That is awesome.
So it's science and rock and roll. So.
Just had to get that out there. Just had to know.
Yeah.
Okay.
Good catch. Good
And I
catch.
see that you have brought a fire extinguisher.
Yes.
Are we gonna need this? What are we doing?
We will. Not for the first experiment. So we'll have that on standby. But so again, safety first. We always want to have precautions in case something were to go terribly, terribly wrong.
Well, let's hope it doesn't. Okay, so the first of our 2 experiments today, what are we doing?
All right. Well, we are going to make a lava lamp.
Ooh.
So I never actually had a lava lamp as a kid. I thought they were really cool, but I never had one. So we can make our own.
What do you do if your goggles start to fog? Because mine are like...
Just air it out. Sweating, same.
Hold on, I have to see what I look like. I can't do this video without knowing what I look like. This is too much.
I'm sweating.
I got up and fixed my hair. I'm vain. What can I say?
So what we're going to do is make a lava lamp. So I'll make it kind of small. What we're going to use here, this is not labeled, but this is extra virgin olive oil.
Okay.
We have, instead of water, I know usually you see a lot of water and oil experiments that are done to kind of mix it up and give it a little bit more color and flavor. We're using like a cranberry juice
Ooh.
for the other substance.
Now, what do they use for a real lava lamp? Do you know?
I actually don't. I think it's more of like a heat-based thing because when you turn lava lamps on, they get really warm.
Okay.
So, but this is kind of your cheapy do-it-at-home version, so
Cool.
more economic, if you will.
And edible.
Yeah, I would need the oil.
If you feel.
We'll go ahead and we'll start with the oil. Had this put into a nice little container because I didn't want to spill this everywhere. So we'll go ahead, put some oil in there, fill it up. We'll start there. This is inexact science. Calculated guesswork, if you will. So we have our oil, and now we're gonna pour in our juice.
Okay. I'm trying not to look too amused by how amazing this already looks. Ooh.
All right, so now we have our juice and oil mixture together.
Wow.
And of course, these two are immiscible, meaning that they will not mix together. So we'll let that settle. So what's happening in here basically is we have a couple different things. So we have intermolecular polarity, meaning so oil is hydrophobic. So oil is scared of water. So it's going to attract more to oil particles than it will water.
Okay.
Or in this case, juice, because we have water as a component of this juice. Whereas water is more of hydrophilic, means that they love water. So water wants to be with water, oil wants to be with oil. So that's why you'll see the two different layers of substances there.
Gotcha.
Another consideration too is density, of course. The more dense a material it is, it's basically that you have a lot of stuff in a certain volume.
Okay.
So if it's more stuff in that volume versus less stuff in that volume, it's going to be more dense and it's going to sink to the bottom. So,
alrighty.
more scientific terms here. So, this is leveling out kind of nicely. Actually, it's very pretty. It looks like Gryffindor. Harry Potter. I'm going to go ahead and try to put a seltzer in there.
Yes. Now, what exactly is a seltzer tablet?
So,
'Cause I don't even know what it is.
according to this, anhydrous citric acid is an antacid, aspirin, sodium bicarbonate.
Interesting.
Sponsor us.
Give us your money, please.
For heartburn, upset stomach, acid indigestion with headache and body aches.
So what about diarrhea?
So, no, you're out of luck on this one. So we'll go ahead and open up our seltzer tabs. And then, whenever you pop seltzer into water, how it fizzes?
No.
Well, it does.
I've never seen one of these.
So,
Okay. Wait, are we doing it? Is this the experiment? I'm nervous. I need a moment.
it's not going to blow up.
Is
It's
this
okay.
gonna work? Is this gonna do something?
It's gonna
Do we
work.
put on our goggles?
Sure.
I
No,
feel like
let's
I'm
go.
not prepared.
Safety first.
Although mine are
Just
gonna
go.
fog because
It's hot. So,
it is hot. Okay, we're doing it.
you're dropping the seltzer. It's going to sink down to the bottom where the juice is, where it's going to create air bubbles.
Ooh.
And then as it travels up through the oil, it gives it that lava lamp kind of look. So it's a lot of fun. It's really cool. Very pretty,
Wow.
I think. I love the colors. You
I
can
don't know if you
hear
can
it.
hear the bubbling sound, but it sounds really cool. So how long will this reaction last?
So it will last about as long as it takes for that seltzer tab to dissolve. So once it dissolves, this reaction will stop, and then you just add more tablets for more fun.
Wow. So this is definitely something cool that you can do at home. Just
A
to
lot of seltzer in there.
Oh my gosh! Did I put a cap on? Or no? What will happen if I put the cap on? Will it cause it?
It'll build up a little bit of pressure.
Okay.
I don't think it'll be enough to explode, but you might make a tiny missile. I'm just kidding.
We have a fire extinguisher. We're gonna be fine.
We're prepared, it's fine.
To sum up this experiment, what is the chemistry that's going on here again?
So intermolecular polarity between water and oil, and then you can also consider density as well, so the heaviness of a substance per its volume.
Wow, very cool. So now we're going to do the second experiment, which I have no idea what it is, but it looks kind of frightening. We've got pipes and Ghostbuster looking materials here.
Some lighters,
We've got things that look really scary.
cornstarch.
I'm not sure what's going to happen here. So what would you call this second experiment?
So this is about dust explosions. So the place where I work, there is a risk of combustible dust. Commonly, you'll see this a lot in like grain mills and grain elevators, things like that.
Oh, wow.
There's a lot of other videos out there where they do similar experiments, kind of talk about that, and that's not the industry I'm in. But it is a common hazard in many forms. But what we have here for our dust explosion that we're going to create is just regular cornstarch. Cornstarch in itself is not going to be combustible. It won't burst into flames when you have it in its normal, like, powdery form. Oh, good point. Safety first.
Oh my gosh.
So if you try to set this on fire, it may singe it a little bit, but it's not going to ignite and it's not going to explode.
What is cornstarch made out of?
Corn.
I'm really smart.
Don't ask me questions. And there's probably other things in it too.
Okay, just wanted to let you guys know, once again, we're going to reiterate for my insurance company that we do have this here. This.
Pull
We have
and
it.
squeeze, sweep, pass.
What she said. Okay,
Yeah.
we're good. All right. let's start blowing stuff up.
We have a propane tank here, so this is what we're going to use to create our flame.
Okay.
So this is our ignition source. We also have here just a little kind of ketchup bottle of cornstarch, which we saw earlier, and so we're going to use this to create our cloud, our dust explosion cloud, if you can see that. And turn this on.
Woo.
It's very loud. Okay, so I'll pick it up.
Oh my god. Wow.
Whoa!
Oh my gosh. So what exactly happened?
So when you have a combustible dust like this, again, like when you have it kind of in a pile like this, not dispersed in the air, it's kind of just in like solid, it's not going to ignite. When you disperse it into a cloud, at that point, if you have oxygen in an ignition source, some of those little tiny particles of the cornstarch will catch fire, and as those catch fire, the neighboring particles will catch fire, and it just leads to kind of this chain reaction, and it'll eventually lead to a dust explosion.
Oh wow. So you're saying that in grain mills, this could actually happen to people just working there. So they have to actually take major steps to prevent a giant dust explosion?
Yeah.
Okay.
So,
wow.
it's
That's
serious. It's
really
legit.
nerve-wracking. So I see that you've got this pump over here. So what is the situation with this one?
So this is same experiment, just different scale. So a little bit bigger. I think what we'll actually do is, so we have the air pump where we can pump the air. We have this nice little funnel attached with duct tape.
Okay.
Very fine engineering.
Very safe also.
Yeah. We'll fill this funnel with cornstarch, and then whenever we blow air into the hose or use the air pump to send that air through, it'll disperse into a cloud just like we saw before, just a little bit bigger, and then over the same flame where it will ignite.
Awesome.
Yeah.
All right.
All right.
Rest
Ready?
in peace, my studio.
Get the propane flowing.
Okay.
Then we'll pull this.
Woo! Okay, so then I'll hold this steady and it will pump. Oh! Oh my! And we forgot.
Sorry.
No, I forgot. Safety first. For a second. Or not at all. Okay, let's do it again.
And we just go fire. Oh no.
Okay, we're back in the melee. My goggles went flying. I don't really know what happened. We almost lit the studio on fire, but we're good. Didn't have to use this. We're just out of breath from fanning the fire alarms and getting everything done. But anyway, so as you can see, a dust explosion is very serious. It's very dangerous.
So sorry.
So, perhaps don't try this at home with your children. You can just watch our video.
Yeah.
So I can actually see now, even just a small amount of cornstarch, how dangerous this could be if there's an explosion. So it's part of your role to kind of make sure this kind of thing doesn't happen and prevent things and figure out ways to prevent all this stuff from happening.
Yeah, absolutely. Proactive versus reactive. So we want to prevent a fire from happening, not fight a fire once it happens. So not my best work.
Well, this is actually really cool. I didn't know any of this. Like I said, I basically had to take remedial math and science classes in college, but I'm very glad I got to see it. I'm also glad the studio didn't burn down entirely.
Same.
You know, and this was awesome.
It was fun. Yeah. Thanks for having me.
All right, guys, that's going to wrap up what we've got for you today. I'll see you next time.
Tea.
Listen, I don't know what to do. I need to do Part 2 of this experiment. Because, oh my God.